Vision is one of our most important senses. It allows us to interpret the environment in front of us, combining information with our other senses. In this paper, I will be discussing a research study conducted by Milton and colleagues looking into the neural markers of aphantasia and hyperphantasia. Interestingly, the researchers of this experiment recently coined the term aphantasia in 2015. So, what do we know? As it stands, we know that aphantasia is a lifelong lack of visual imagery. If you look at the image on the screen, try to imagine an apple in your mind. If you see nothing, congratulations, you have aphantasia. However, if what you see is so realistic your eyes might as well be open, you have hyperphantasia. Before this experiment, the phenomenon of aphantasia was hugely neglected in research, with little being known about those experiencing it and how it affects consciousness. Milton and colleagues wanted to close this huge gap in the literature and investigate the neural signatures of aphantasia, potentially finding a cause to this phenomenon. This paper is the first systematic study to investigate the neuropsychological and the neural signatures of aphantasia and hyperphantasia. As far as gaps in the literature go, this is a massive one. We don't know where visual imagery is located in the brain and what is associated with a lack of visual imagery, such as certain mental and developmental disorders like autism spectrum disorder or prosopagnosia, a disorder characterized by a deficit in the ability to recognize faces. This paper begins by discussing previous variations in the methodology, such as Galton's breakfast table questionnaire, as well as focusing on the fact that these researchers first defined aphantasia in those words. Milton et al. Hypothesized that autobiographical memory would be most implicated in aphantasia, as well as higher order visual areas and the limbic system. They also hypothesized impairments in future and atemporal imagination, facial recognition as well. In terms of neural implications, the team predicted differences in personality, with aphantasic participants displaying autistic traits, while hyperphantasic participants would demonstrate extrovertedness and openness to experience. The participants ranged from having aphantasia, hyperphantasia, and average imagery vividness as reported on their recruitment questionnaire. Moving on to the study itself, the researchers looked at a range of behavioural and neuroimaging methods. Each method used in this study featured extensive protocols and procedures, so I'll only be focusing on two methods. Anterograde memory, where the 69 participants took a test to study their memory, and task-based functional MRIs, where participants underwent fMRIs while completing visual imagery tasks. Participants were asked to utilize their visual imagery skill, or lack thereof, to imagine future events or visualize certain objects in their mind's eye while under investigation. On to the results. For the behavioural methods examined, there were no differences between the groups on anxiety and depression scales. However, using the Big 5 personality scale, hyperphantasic participants were far more extroverted and open to experience than the aphantasic group. Anterograde memory showed no significant differences between groups. Meanwhile, participants in the hyperphantasia group had much stronger autobiographical memory, able to recall significantly more details than those with aphantasia. In terms of imagination, there were small differences in the strength of imaginations between groups, but not statistically significant. Using a prosopagnosia test, participants in the aphantasia group had some difficulty recognizing buildings and faces, but not significantly so. As you can see in the slide here, those in the hyperphantasia group showed more activation in the left anterior parietal region in the precentral gyrus than participants in the aphantasia group. As well as this, parts of the cerebellum within the posterior and anterior lobes and parts of the thalamus were more strongly activated in hyperphantasic participants under task-based fMRI. The difference in brain activation provides strong evidence for a neurological basis for aphantasia, but it does raise more questions. The future of aphantasia research is looking really bright. On the slide here is a few examples of where the research could lead. Aphantasia could have a strong basis in autism spectrum disorder, with many participants in the aphantasia group presenting with autistic traits. Leading from this, there could be more research into the Big 5 personality traits and their potential neurological basis. Differences in brain structure are evident, with brain activation being stronger in the hyperphantasia group. This could lead into potential treatments for aphantasia through therapies targeting imagination and visual imagery, potentially strengthening long-term autobiographical memory. The study itself has some very intriguing implications for the results. In terms of consciousness, a lack of visual imagery could suggest that there are perhaps limits to what our consciousness can access. Visual imagery vividness may very well be a process that we have to be aware of to be able to use. Less abstractly, there is a neurological foundation, as this study found, leading to more concrete evidence that aphantasia is a real phenomenon and not just a difference in explanations given by those with less vivid visual imagery, with reference to anecdotal and experimental measures to determine visual imagery vividness extremes. The personality differences highlighted in the experiment also show that hyper and aphantasia may be a result of, or can cause personality differences such as extrovertedness. Leading on from this, it could also explain potential comorbidities such as autism spectrum disorder and prosopagnosia. Memory is also seen to be implicated in aphantasia, meaning that those with the condition have weaker autobiographical memory, being unable to evoke sensory details of their memories, such as smells and sights, which can have profound impacts on cognitive processes. Overall, this is a really fascinating topic to delve into and learn more about. Perhaps today you learned that you have aphantasia or hyperphantasia and are part of a small percent of the population who experiences these visual imagery vividness extremes. Even before reading this study, I knew I had aphantasia through experiences in my youth, and perhaps that's the same for some of the listeners. Thank you for listening. I've provided the link to the research study should you wish to learn more about this amazing phenomenon.